Bismillahirrahmanirrahim. Our lecture is analysis of function using derivatives. In this lecture, we will study how to find out rising or decreasing function, relative maximum or relative minimum, concavity of the curve, that is facing upwards or downwards, absolute maximum or absolute minimum, and point of inflection. So the first derivative test, f dash of x, includes rising function, decreasing function. So from the figure we see that the curve rises from x0 to x1 and the result of the first derivative is greater than 0, which is positive. So we will always have a rising function and relative maximum. In the second picture we see that the curve point x0 moves to x1 and the result of the first derivative is less than 0, which means it is negative, and in that case we always have a decreasing function and a relative minimum. Now when f dash of x goes to 0, so we say no change or a constant function. As shown in the figure, f dash of x is equal to 0 and it is assumed that it is a straight line. Now the second derivative test, f double dash of x. In this we will study concavity and absolute maxima and absolute minima. Now here in the figure we see that the point x0 moves to x1 and then to x2. It gradually rises and then it falls. The result of second derivative is less than 0, which means the result of the second derivative is negative and the curve is facing downwards, and in that case we have absolute maximum. Now in the second figure we see that the point x0 moves to x1 and then rises to x2, and the result of the second derivative is positive. So the curve shapes upwards, or we can say that it is concave upwards, and in that case you have absolute minimum. So when the result of the second derivative is equal to 0, we say no change or a constant function, as shown in the figure. Now the point of inflection. This is the point at which the curve changes its concavity, and either from facing downwards to upwards or from facing upwards to downwards, as shown in the figure. This is facing downwards because the result of the second derivative is less than 0. Then it is concave upward at a point which is shown is the result of second derivative is greater than 0, and so on. So the point of inflection is x0 is equal to a, and in the another case if it has more than one point, x1 is equal to a. So these are the 2 points of inflection shown in the figure. The point of inflection may be 1 point, 2 point, or depending on the critical values of the function, as we have already seen in the figure. Now how to locate the point of inflection? Now from the previous lecture we have seen that the point of inflection is the point that changes the concavity of the curve. So when the result of the second derivative is negative in one half and then it is positive in the another half, or first one is positive and then the second one is a negative, we can find out the point of inflection as subtracting 0.5 from the expected value of the point of inflection and add 0.5 to the expected value of the point of inflection, and then put the result in second derivative and check the sign. If the sign of these 2 points are opposite to each other, which means either negative and in the second half it is positive, then that point will be the point of inflection. Otherwise, if the points, the signs are same, then that point, which is suppose x0 is equal to a, will not be the point of inflection. And we will repeat all these procedures in order to evaluate the rest of the expected point of inflections. Dear students, for examples, we'll see the next video.